Hi everyone, I wanted to show you briefly how to rearrange the E equals hc over lambda equation if you are given the energy and need to solve for the corresponding wavelength. Remember that we have this E equals hc over lambda, and this equation is arrived at by using the C equals lambda nu, and E equals h nu. We can solve for a frequency in this one and substitute that into here. And that's where we arrive at this direct relationship in an equation that actually allows us to solve for wavelength directly in one step versus using two steps. Okay, so remember that the really prudent thing to do when you're solving algebraic equations is to solve for the unknown variable first before you plug any numbers in. And then once you have your variable isolated on one side, then you're going to be able to plug the numbers in, and you're going to really reduce the amount of errors that you make. Okay, so let me just show you how to do that. So I'm going to scroll up here. So we've got this E hc over lambda. So if we're given energy and we want to solve for lambda, I need to isolate lambda on one side. And so I need to get it out of the denominator here. So I'm going to do that by multiplying both sides by lambda. So here I've got lambda in the numerator and in the denominator, so this will cancel. So now I'm left with lambda times E on this side equals H times C. Now I want to solve for lambda and isolate lambda on the left side. So I need to divide now by E. All right, so that's going to cancel over here. And that is going to leave me with lambda equals H times C over E. All right, and this is the equation that you can use to solve for lambda when you're given a value of energy. So let's quickly think about what units we're going to be getting here. My H, Planck's constant, is in joules seconds, so joules times seconds. C is in meters per second, and energy is in joules. All right, so that gives me like joules seconds times meters per second divided by joules. So this cancels, so I'm left with my wavelength in meters. Okay, so what you might need to look at in your question is whether or not the question is asking you to give the wavelength in another unit besides meters. And if so, typically it's going to be nanometers. And you need to then convert that value that you solve for here into nanometers by using the conversion factor. Every 1 meter is equal to 10 to the 9th meters. All right, and so that will be contextually given in the question, whether or not you need to do that. All right, but hopefully that helps you see how you can use that E equals hc over lambda to solve for wavelength when you're given the energy in the problem.